100 into 10 raised to minus 3.
No. This is 1 kg force, which is also equals to 1 kg weight. And if you have to convert it in terms of Newton, just multiply this particular numerical value by the numerical value of gravity. So it will be gravity times Newton. Take gravity to be 10, so it will becomes 10 Newton. So 1 kilo force equals to 10 Newton. So we have 100 kg force, so multiply it by 10 since we have gravity as 10. So total force in this condition is 100 multiplied by 10 Newton. Is it clear?
Yes, sir.
And there is displacement of its top by 20 centimeter with respect to bottom. So X is 0.25 in terms of centimeter. So if you want to convert it into meter, just multiply it by 10 to the power minus 2. So calculate shearing stress, strain, shear modulus. Side of this particular cube is 10 centimeter. So area will be side square, 10 centimeter multiplied by 10 centimeter, divide by 100, divide by 100 to convert into meter square. So it will give you 10 to the power minus 2 meter square. Is it clear?
Yes, sir.
Now we have force. We have area of cross section. So just divide these two parts, you'll get stress. Is it clear?
But sir, we need shear stress, right?
Yeah. So shear stress is force divided by area of cross section. So in first part, shear stress equals to deforming force by area of cross section. Deforming force we have 1000. Area of cross section is 10 to the power minus 2. So it will be 10 to the power 5 Newton per meter square. Is it clear?
Yes, sir.
For the second part, shear strain, we have a cube whose vertical length is 10 centimeter and shift from its actual path from this point to this point due to deformation or bending. On application of shear force, X, which is about 0.25 into 10 to the power minus 2 meter. This will be in terms of meter 10 to the power minus 1 meter. So shear strain is nothing but theta. So it will be equals to X by L. Is it clear?
Yes, sir.
So we have X as 0.25 divided by L 10 to the power minus 1. So on solving, you'll get 0.25 into 10 to the power minus 1 or 0.025. Is it clear?
Yes, sir.
Now,
In this one, I got 0.025.
Good. So just divide these two parts, you'll get amount of shear modulus. So related to this, shear modulus will be stress divided by strain. Remove this decimal. So put 10 to the power 3, or you may write 1000. $25 and 40 be 1000. So you'll be 4 into 10 to the power 6 Newton per meter square as shear modulus. Is it clear?
Yes, sir.
Okay. So how much you have attempted?
I did first question and the second question. No, second question also I didn't do it properly.
In this part, you have a square laid slab of side 50 centimeter and thickness 10 centimeters subjected by a shearing force on its narrow face. Okay. Of this much amount and lower size out to the floor, how much will the upper face displace shear modulus is this? So we have side 50 centimeter, thickness 10 centimeter and subject by shearing force on its narrow face. So it will be towards this top face is square in shape and width is 10 centimeter. So this is 50 centimeter and this is also 50 centimeter, on which a force is applied along this direction. And in this part, its base is kept fixed. Is it clear?
Yes, sir.
Now we have force. You can find area of cross section of this top surface by multiplying length into breadth. Length is 50 centimeter and breadth is 10 centimeter. Convert into first into meter and then find area in terms of meter square. So according to formula, stress equals to force divided by area of cross section. So force we have 9 in 10 to the power 4 divided by area of cross section, length into breadth, 0.5 into 0.1. Any doubt?
0.5 and 0.1 is
0.5 is its length. For 50 centimeter, I've converted into meter by dividing by 100. And 0.1 is due to 10 centimeter. I have converted into meter by dividing it by 100.
okay, sir.
Any doubt?
No, sir.
You have to calculate or you have to solve only 3 or 4 of this particular paper, not the whole part. Similarly, you may find third question as well as fourth question. Okay.
Okay, sir.
Okay, so we have done up to gauge pressure in last class. Any doubt related to that part?
No, sir.
Noor, when is your final exam?
Teacher, sir, they didn't say for sure, but they said either in January or February.
January?
No, February or March. Yeah.
Okay, okay.
Sorry.
Now, on the basis of pressure, let me give you some question. First, let me define you Pascal's law. It simply states for stagnant liquid or liquid at rest, at any particular column, pressure will be independent of direction. It acts equally in all direction. So we have to prove this statement. Let me define its statement. It says for liquid at rest, at same horizontal level, pressure will be same in all direction. Suppose you have container in which liquid is filled up to this level. Suppose you have a cross section on which a force is acting normal to it along this direction. Let's say area of this particular segment is A. So we have to calculate pressure acting due to this segment and its various component. Let me define you. For this component, having area A, draw a vertical segment and similarly horizontal segment. Let's say this particular inclination is theta, this one. So this A will have two components. One will be adjacent to its base from this point to this point, A cos theta, and one will be perpendicular from this point to this point, A sin theta. Noor, is it clear?
Yes, sir.
Now, for this particular surface, since we have two different components, one is perpendicular to it and one is adjacent to it, having inclination theta. So let me calculate component of force acting.
So why are we drawing the component?
We have to calculate pressure on different segment. That's why we are calculating segment or component of area as well as component of force. Okay.
Okay.
Let's say this force is normal to the surface. So draw a horizontal line and a vertical line. So if this is theta, this will be 90 minus theta, and for this will be theta. So this component will be F cos theta, and this component will be F sin theta. Any doubt in this breaking of component?
Sir, I didn't understand this one.
Okay, just 1 minute. Let me define you how to break component. Suppose you have a vector from this point to this point, A, which is inclined at some inclination theta with respect to x-axis. So this A, draw a vertical line and a horizontal line. So from this point to this point will be AX, and from this point to this point will be AY, which will be this term. Is it clear?
Yes, sir.
Now, using trigonometry, if you have to calculate cos theta for this part, so cos theta will be base divided by hypotenuse. So we have base as AX and hypotenuse as A. Is it clear?
Yes, sir.
So if you want to calculate AX, so move this A to left side, so you'll get A times cos theta. Is it clear?
Yes, sir.
Similarly, Sin theta equals to perpendicular divided by hypotenuse. So if you want to calculate AY, it will be A times sin theta. Is it clear?
Yes, sir.
So from this part, we have concluded whenever you have to calculate component of a particular vector A into its adjacent segment on either side, one is along theta and one is along perpendicular to it. So x component or the component which is adjacent to theta will be equal to vector times cos theta. And similarly, a component perpendicular to it that will be termed as y component equals to vector times sin theta. Is it clear?
Yes, sir.
So in this part, I have a component A, which is inclined at some angle theta. So the component adjacent to this particular theta must be multiplied by cos, and the component adjacent or perpendicular to it will be A times sin theta using this concept. Is it clear?
Yes, sir.
This is called resolution of vector or breaking of component of vector into their respective axes. Any doubt?
No, sir.
Now let me define you. Let's say this is surface 1, this bottom is surface 2, and this is surface 3. So let's say for surface 1, pressure equals to force divided by area of cross section. For surface 1, force is F and area is A. So pressure will be just F by A. Is it clear?
So can you say this once again? The surface.
This was a surface having area A, and this was the force which is acting normal to the surface. So force acting per unit area is called pressure. So pressure will be equals to force divided by area of cross section. Is it clear?
Yes, sir.
Now for surface 2, that is this surface, we have area as A cos theta, and the force acting on that surface is F cos theta. Is it clear?
Yes, sir.
So for surface 2, pressure equals to force divided by area of cross section. Force we have F cos theta and area A cos theta. Cos theta and cos theta cancel out. So you're left with F by A only. Let's say this is equation 2. Is it clear?
Yes, sir.
Similarly, third part for surface 3. Just tell me amount of force acting and area of cross section on it. For surface 3.
Sin theta by A sin theta.
Good. So F is just F sin theta and A is A sin theta. So sin theta and sin theta cancel out. So you're left with F by A only. Now just compare equation first, second, and third. Are they equal?
Yes, sir.
So we can say at same horizontal level, let me define with these direction. P1 will be along this direction. P2 will be along this direction. And P3 will be along this direction. P1, P2, and P3. So at same horizontal level, pressure is independent of direction. It acts equally in all direction. Is it clear?
Yes, sir.
So from equation first, second, and third, we can say P1, P2, P3 equal to each other. Okay, just write it down.
Yes, sir.
Done.
Yes, sir.
Next application of this Pascal's law is, it says for enclosed vessel containing incompressible liquid, let's say there is a piston at this point. There is a piston at this point. And at this point. Now, if this liquid is incompressible and enclosed in this particular vessel, so if a pressure is exerted at any one end, let's say a pressure P1 is exerted at this end, so it equally acts at this point and at this point without getting changed. So for an incompressible liquid in enclosed vessel, the pressure exerted at any one end get transmitted equally in all direction without getting diminished. It means this vessel is enclosed and this liquid is incompressible. So we have exerted P1 pressure from any one side. So this will be equal to P2 as well as P3. Okay, Noor?
Yes, sir.
Okay, just write it down. Then let me define the application of this Pascal's law.
So I have written it.
Oh, good. On the application of this Pascal's law, there is an instrument called hydraulic lift, which is used to uplift heavy vehicle by applying very small amount of effort on it. Let me define you. There is a piston at this point. Another at this point.
Sir, incompressible liquid means like a liquid you cannot press.
Compress it.
Right?
Yeah, we can't change its density.
But like for liquid, you cannot change density, right?
Yeah.
For any liquid.
No, we can. But in this pass, we are assuming even we can change or deform solid according to the concept of elasticity, stress, strain. we have elongated solid to further some stretch length and something more. So we can compress or expand fluid as well. But in this part, we are assuming fluid to be incompressible so that there will be no change in density. Is it clear?
Okay. Yes, sir.
Let's say this is an arrangement in which there is incompressible liquid filled in this particular entire system. And we have two pistons, one is at this point and another is at this point, having different cross-section area. Now, if a force is applied at this F1 over area of cross-section A1, so pressure at first point will be force divided by area of cross-section. Let's say this is equation first. As a result, it will exert a force in upward direction F2 having area of cross-section A2. So pressure at point 2 will be force divided by area of cross-section. According to Pascal's law, if this entire system is enclosed and liquid is incompressible, so P1 and P2 must be equal to each other. So we can write from equation first and second, using Pascal's law, we can say F1 by A1 must equals to F2 by A2. Is it clear?
Yes, sir. Sir, will
Okay.
they ask how it is equal or why it is equal to write in words, or we just have to prove it with
No, you have to write, you have to equate. You will say equation first and equation second. You can say using Pascal's law. Since liquid is incompressible and enclosed in a vessel, so pressure exerted at any one end must equals to pressure exerted at the other end using Pascal's law. Is it clear?
Yes, sir.
Just write it down.
Finish, sir.
In hydraulic lift, if a ratio of their radii is 1:3, a force of 20 Newton a force of 20 Newton is applied at smaller piston. Find force exerted on larger end. Just use the above formula. Write area as pi r squared since pistons are circular in shape. Put their values and simplify it. You have to find the value of F2. In this question, we have F1 as 20 Newton. Ratio of R1, R2 is 1 by 3. So we have to calculate F2. Just use the above formula and try to find.
Sir, 60 Newton.
You have done a little mistake. You haven't squared the radius. Using the above formula, you can say F1 divided by A1 equals to F2 divided by A2. So move F2 to left side and A1 to right side. Or you can write F2 equals to F1 A2 divided by A1 like this. You may further expand area as pi R2 square divided by pi R1 square. So pi and pi gets cancelled out. So you're left with F1 R2 divided by R1 whole square times F2. Now put the value of F1, R1, R2.
Sir, how do you square 3 by 1?
We have F1 as 20 and R2 divided by R1 will be 3 divided by 1 whole square. So numerator will square individually and denominator will square individually. So you'll get 20. Square of 3 will be 9 and square of 1 will be just 1. Is it clear?
Yes, sir.
So 20 into 9, it will be 180 Newton. Is it clear?
Yes, sir.
Now just compare how much you have applied and how much we are getting. So you'll say this hydraulic lift is used to generate but large amount of force so that to uplift very heavy object on applying very small effort. Is it clear?
Yes, sir.
You have written?
Yes, sir.
Now let me define you some theoretical question related to this part. There will be a question. The average surface area of human being is 1.5 meters square. Find net force due to atmospheric pressure. Just tell me the value of atmospheric pressure, what we have calculated in last class. Tell me the value of 1 atm.
76 centimeter
of Hg in terms of
of
Pascal.
mercury. In terms of Pascal, 1.013 into 10 raised to 5 Pascal.
Good. So we have in this part, Pascal pressure is, you may write 1 10 to the power 5 Pascal. Area of cross section as 1.5 meters square. So if you have to calculate force exerted, so according to the formula, force will be equals to pressure into area of cross section. Pressure is 1 in 10 to the power 5 into area of cross section is 1.5. So you'll say force will be 1.5 into 10 to the power 5 Newton, which is similar to carrying a load of 1.5 into 10 to the power 4 kg on our back. Will it be possible to carry this much amount of mass on our body?
No, sir.
You can hardly carry a mass of about 100 kg. And this is about 15,000 kg. Is it clear?
Sir, but I didn't understand that how this is similar to 1.5 into 10 raised to 4 kg.
No. I've just calculated 1.5 10 to the power 5 Newton and converted in terms of mass by m into g. So the value of gravity is 10 divided. So the total mass due to or on applying this much amount of force will be about this much. Is it clear?
Okay. Yes, sir.
So it will be 15,000 kg. So the total force experienced by any human on an average is about carrying of 15,000 kg load on their body. But we simply live freely on the surface of Earth. We feel nothing. Why? Let me define your mechanism behind it, why we can't feel any effect of this enormous pressure due to atmosphere on our body. You have bio or maths?
Bio.
Good. So you must have learned about epithelial tissue, which is covering all our body, that is skin. Let's say surface of skin consists of small pores. There is tissue just below this layer, which is adipose tissue. So there is a layer of fat stirring tissue just below this. And also there will be blood stream flowing across it. So there will be some blood pressure towards this direction, and due to pore on our skin, air from outside get entered into it and get filled the bubble of adipose tissue, and they will exert pressure towards outward. These two terms will exert pressure which becomes equivalent to pressure exerted by atmosphere on our body. So as an effect, net force acting on our body will become zero. That's why we feel nothing. Is it clear?
Yes, sir. So blood pressure and adipose tissue, both of them are showing pressure towards the spore.
Outer side towards atmospheric pressure, and there will be pressure from outside due to air. So this will be blood, and this will be air filled in bubble of fat or adipose tissue. These two combines together to exert pressure in outward direction to balance that atmospheric pressure. Hence, net effect acting on our body becomes zero. Any doubt?
No, sir.
Okay, just write it down till this part.
Finished.
Now, the next question is, suppose there is an individual which is in this position, and there is another individual which is at this position. Will there be any pressure difference at different position, at lying position and vertical standing position? Let me define you. In first part, at this point, since they are at same horizontal level. So in last class, I defined you at same horizontal level, pressure will be equal at any instant. So this is at head. So pressure at head, and this is at toe. These two pressure must be equal to each other. But in standing position, at this point and this point, there will be pressure only from outside on our head. That will be atmospheric pressure. But on our toe, there will be pressure due to two different segments. Just 1 minute. So in the second part, on our head, there will be pressure only from air. That will be atmospheric pressure. But at our toe, there will be pressure in two different segments. One is atmospheric pressure, and the other due to blood stream, which is connected in all our body and which must be exerting some gauge pressure on toe. But there is no any column of blood just above our head. So at toe, there will be atmospheric pressure plus pressure due to blood. So net pressure at point 2 will be always greater as compared to head in vertical standing position. Is it clear?
Sir, the head one will be, the vertical position one will be more pressure, right?
No. You will be asked why pressure at feet is greater than pressure at head. So you will say at head, there will be pressure only due to air, since there is no any fluid just above head in this position. So there will be pressure only due to air above it, that is atmospheric pressure. But at point 2, there will be two different things that will be exerting pressure at point 2. First, the air column, and the second, due to blood capillaries connected all through our body and which must be vertically placed over that feet. Is it clear?
Yes, sir.
So net pressure at point 2 will be sum of this plus this. So if you compare these two pressure, you will say there is some excess pressure due to blood column placed above feet. Any doubt?
No, sir.
So we can say net pressure at 2 is greater than net pressure at head.
But this is only for when you're vertically standing, right?
Yeah.
And what about when the person is lying down horizontal?
So pressure will be same at all position, since there is no vertical column at this lying state. Okay.
Okay, okay, sir. So I'm done.
Okay. Next will be acceleration of liquid horizontally. Suppose you have container in which liquid is filled up to this level. So at point A, at point B, there will be always also, there is only atmospheric pressure. Now, if this entire vessel is being accelerated towards right, at some acceleration A, so what will happen to the level of liquid? Will there be any change in level of liquid?
Yes,
Yes.
sir.
Towards which direction?
Towards the backward direction.
Good. So the level of liquid may get change like this. So if you draw a horizontal line, let's say this inclination is theta. This will be change in level of liquid, h. This is length L. So A will be equals to G times tan theta, and tan theta will be equals to perpendicular by base. So G will be H divided by L. Is it clear? Noor?
No, sir.
Okay. Let me calculate this. In the last part, I defined you how much gauge pressure will exert at any particular point. So gauge pressure was rho GH. So you'll say in this segment, G is the acceleration with which this liquid will be accelerating so that it must be exerting some pressure on its bottom portion at that particular point. Similarly, in this part, due to acceleration of system towards right, there will be some pressure at this point due to acceleration towards right. Is it clear?
Yes, sir.
So let's say this point is A. So pressure at point A due to acceleration towards right will be density of liquid, acceleration A times length of column of liquid which is accelerating, so which is L. Is it clear?
Yes, sir.
So rho, just convert this A by G tan theta or G times H by L. So G times H by L multiplied by L. So L and cancel out. So you're
Sir,
left with,
why are you
yes,
converting it into G into a H by L?
so that to compare the net force what we have derived earlier. Let me define you first. So H and L will cancel out. So you're left with nothing but rho GH. Now just compare the two pressure, this term and this term. Is it the same?
Yes.
So you will say due to acceleration of this particular entire system towards right, there is change in level of liquid at this point A, which must be exerting pressure at point A, which is this much. But initially, there is no any column of liquid above it, so there will be no pressure at this point A. So we can say on acceleration of liquid towards right, there is some pressure at point A. Is it clear? That's why A will be equals to G times tan theta or G times H by L, so that this term and this term numerically gets equal to each other.
Yes, sir, it's clear.
Good. You'll be asked only acceleration. You'll be given column or level, change in level, and you'll be asked find the acceleration of system. So you'll say acceleration will be always equals to this term.
So I'm done.
Next is U-shaped tube. Suppose you have U-shaped tube like this. Let's say initially water is filled up to this point. So the level of water in 2R will be at same level like this. Now, if some other liquid is filled from any one side, let's say up to this level. So the level of liquid or water may get changed so that it may get reached to this point. Noor, is it clear?
Yes, sir.
Now you have to calculate or how to calculate height, density, pressure, and so on. So you'll say at same horizontal level, at the lowest junction, let's say this is at the lowest junction, draw a horizontal line passing through this towards each arm. So height of column of liquid in this part, H1, and this part, it will be H2. Let's say this point is B. So just remember, at same horizontal level, in same liquid, pressure will be same on either arm. So we can say pressure at point A must equals to pressure at point B. So for this part A, there is a column. Let's say density of this liquid is ρ1 and this liquid is ρ2. So point A, there will be atmospheric pressure above it plus pressure due to column of this liquid ρ1 GH1, and similarly towards second arm there will be pressure due to air plus rho GH2. So using this equation, you may calculate density, height, pressure related to this segment. Noor, is it clear?
Yes, sir.
Okay, just write it down.
But sir, I didn't understand why you drew the first U-shaped.
I've defined you. Suppose you have a U-shaped tube initially and you have filled liquid. It will be at same horizontal level on either side of the arm. Now, if you place some other liquid into one arm, there will be change in level of liquid of same level on either arm due to some pressure difference. Is it clear?
Yes, sir.
Initially, it was at this level, but now on putting some other liquid, pressure level of liquid gets depressed along this side in this arm, and consequently, level of liquid may get increased on the opposite arm by same amount. Noor, done?
No, sir. I was drawing the diagram.
Okay.
So I'm done.
So this is all about Pascal's law and pressure due to column of liquid. Now the next in this chapter is Archimedes Principle. You must have learned about Archimedes Principle in class 9th as well. Any idea?
No, sir.
Suppose you have in which liquid is filled up to this level. Now, on emerging some object into it, Noor, what will happen if you insert any object into this liquid?
The liquid will rise.
The liquid will rise, and then since there is hole, so
The
it
liquid
means
will transfer to the other bowl.
good. So let's say some amount of liquid get displaced towards this. There is some amount of volume which is inside, and there is some amount of volume which is outside. So this is volume immersed, and this is volume outside. So how much liquid this object will displaced? Noor, any guess?
The amount of volume which is inside.
Good. So this must be equals to volume of object which is immersed into this vessel. Now, initially, when object was in air, it must be experiencing some downward force due to gravity. So the weight of object in air will be mass times gravity. Convert mass in terms of density, so it will be rho total volume times gravity. But now there is some decrease in its weight in this liquid. And why there will be decrease in weight, which is defined by Archimedes Principle. So it states when a body is immersed in a particular fluid, partially or completely, it will experience net upward thrust, that is called buoyant force, which is equals to amount of liquid displaced by that particular object. Is it clear?
No, sir, I didn't understand.
Okay, so let me define you this. When a body is immersed in fluid, partially or completely, it experiences an upthrust, which is equal to weight of liquid displaced by the body. This upthrust is called buoyant force. So it says when a body is immersed in a particular fluid, partially or completely, it experiences an upthrust, which is called buoyant force, and this must be equals to weight of liquid displaced by the body. This will be equals to weight of liquid displaced by the body. Is it clear? So
Yes,
let me
sir.
calculate how much buoyant force it will experience. So buoyant force will be
Sir, I
weight.
was asking
Yes.
that W is equal to mg, then how is it equal to sigma?
Okay, okay, just a minute. We had a formula, density equals to mass divided by volume. Is it clear?
Yes, sir.
So we can write mass equals to density into volume.
Yes, sir.
Let the density of object to be sigma and total volume is V. So mass will be equals to sigma into V. Is it clear?
Yes, sir.
Similarly, in this part, Barn force equals to weight of displaced liquid. So how to calculate weight? So weight is nothing but density of that particular object. In this part, we have rho, how much volume it is, Vi, and acceleration G. So this is the formula to calculate Barn force. Any doubt?
No, sir.
Okay, just write it down.
Sir, how is buoyant force denoted as UV?
It's just a representation for upthrust.
Okay.
Upthrust, first alphabet is U, that way it is U. And since this is buoyant force, so it is termed as UB.
Okay, sir. I understand. Thank you. So I'm done.
A cube of density 0.6 gram per centimeter cube having side 10 centimeter is immersed in water so that 3 centimeter remain in air. Find first weight and second buoyant force. Let me define its diagram. There is a cube of side 10 centimeter. For which 7 centimeter is underwater and only 3 centimeter remain outside, like this. Okay, Noor?
Yes, sir.
So use work weight equals to sigma volume times gravity. Write each term in their SI unit and try to find. Similarly, for bar force, rho volume of object immersed times gravity. So if you have to calculate how much volume of this object is immersed in this liquid, so volume is length into breadth into height. We have length 10 centimeter and breadth 10 centimeter. And how much height is immersed in this liquid?
7.
Good. So it will be 10 divided by 100, 10 divided by 100, but for height, it will be just 7 divided by 100. Now just put these values and try to find these two terms.
So we have to use the density of water, right?
Yeah. In case of object, just use this part, but it is in terms of gram per centimeter cube. So multiply it by 1000 to convert into kg per meter cube. So for sigma, 6 into 10 to the power 3, volume 10 divided by 100, length 10 divided by 100, breadth, and 10 divided by 100, height. And the value of gravity is 10. For buoyant force, density of water is 1000. Volume we have calculated 10 divided by 100, 10 divided by 100, and 7 divided by 100, and gravity, which is 10. Just simplify these two terms and compare which is stronger.
Sir, for buoyant force, I'm getting 10 into 7 into 10.
Just check your calculation. Just count the number of zeros in denominator and numerator. We have 3 plus 1, 4 plus 1 plus 5, 6. 6 0 in numerator as well as 6 0 in denominator. So you're left with nothing but just 7 Newton. Is it clear?
Yes, sir.
And for the weight, 0.6, you may remove this decimal and write 10 in denominator and just count how many zeros in numerator and denominator we have. Both 7 7. 7 0 in numerator and 7 0 in denominator. Noor?
So in the numerator, only 5 zeros are there, right?
How are you calculating? This is 3 0, 4, 5, 6, and 7.
Yes,
Okay.
sir.
Try How many zeros in denominator?
7.
So both 7 and 7 will cancel out. So you're left with
0.6. Sorry, 6.
So weight of this object is 6 Newton and buoyant force in this case is 7 Newton. So buoyant force will tend to uplift that object and keep it floating. Is it clear?
Yes, sir.
You have done to this part?
Yes.
Any doubt?
Sir, buoyant force is for an object to like to keep it floating, right?
Yeah, its application is one of the application. Okay, just stop here for today. In next class, I will define you an application of buoyant force and some more term. Okay.
Okay, sir. Thank you.
Okay, thank you. Hello.
Hello, sir.
How are you?
Fine, sir. How are you? What about you?
Fine. Okay, so how much you have done? Any doubt?
Sir, we have done the atmospheric pressure.
Do you have any doubt?
No, sir.
We have done gauge pressure and atmospheric pressure, on the basis of which I have defined you this question.
Yes, sir.
Okay. Now the next term is Pascal's law. Suppose you have a vessel in which liquid is filled up to this point. Now we have to calculate according to this statement. Let me define a statement of Pascal's law. It states for liquid at rest or hydrostatic part at same horizontal level, it will act equally in all direction. It means pressure exerted at any particular depth will act equally in all direction. Hence, it will be direction independent. That's why it is termed as scalar quantity. Is it clear?
Yes, sir.
So, according to Pascal's law, it states for hydrostatics, or for liquid at rest,